Okay. How do I go to a new page?
You can use your finger to scroll up.
No.
And if you need a new page, I can do it for you.
Okay, that's okay. Okay, so one thing I want to comment on about project 2 is, because I noticed a lot of people had it right, but I'm just curious like if anyone can explain this. So in the finite element formulation, we're solving Laplace's equation, and we've got Neumann boundary conditions. And so we've got this integral to compute, pretty much. Sine times some test function over the boundary of the domain. I prefer calling this gamma. So a lot of people, you had it right. I'm just curious if you can comment on how these integrals came out. How do I want to show this? Because there's this one integral. I'm just curious, because I think there's some people that they wrote that they had. Let's say there was a 0.5 somewhere. You guys remember putting a 0.5? Some people were very honest and they said, I don't know where this comes from, but it seems to work. So can anyone maybe explain why there's a 0.5 when you do this integral? Let me just write it this way. Well, I guess I'm basically giving it away. Yeah, okay, I'm giving it away. But the point is if you're confused about where the 0.5 comes from, we're integrating this basis function, basically, because this is we're using the same basis function that we're using to represent our solution. And so when we want to compute this integral with a non-homogeneous Neumann boundary condition, then we end up with g, which in our case g was just equal to 1. And so it's just basically the integral of 0 to 1 of s dx.
S times ds.
Oh, sorry. Yes.
What is S?
It's just a parameter that controls our basis function. Yeah.
It's the coordinate along the boundary.
So if this is, it's coordinate along the boundary, so S, we would have along an edge a basis function that's equal to 1 at one node. At S is equal to 1. So if we parameterize an edge, let's say, along the boundary from 0 to 1, then it's going to be S. And then the other basis function, let's say, coming from the opposite node is going to be 1 minus S. But anyways, I just wanted to clarify that because it's something that's on project 2.
The half comes from like the integral of like a triangle over